Alright, let's get right into the video. There are a couple topics I want to go over, but first let's go over the subgraph that makes it all possible. Because the problem we face right now is that splines are difficult to work with in their default state. So the first thing we're going to need is the subgraph that splits those splines into usable segments. This is what the graph will look like in its final state, but we'll be making it from scratch. Now I've already copied over the necessary inputs. Alright, now let's create that new graph. Drag it over as a loop. And I'm also going to drag out the output since we need a lot of space. Now to set up those inputs, we're going to need the in loop, the intersections, the cuts, the streetwide positive, the streetwide negative, the length, the offset, and the water. We'll also break these connections here so we can see what we're working with. Now let's drag the blueprint into the empty level. Now let's explain how this works. At the moment, our roads are one continuous line that we need to split into smaller segments. If you try to connect our roads directly into a spline mesh spawner, it will completely ignore any spacing or intersections. So what we're going to do is get the point at which the intersection occurs, and then use the index of that point to split the spline. Alright, let's start by making reroute nodes for later. Now get a copy attributes node. And what we need to do is copy over the index into a new attribute called saved index. Next, we're going to need an intersection node, and for that we're going to merge the intersections and the cuts. And we also need to make sure the density is set to 1. Now we create a point count and create a branch node. Since we only need the loop to happen if there's an intersection. Next we do a sort points and sort by the saved index. Next we're going to divide 1 by the amount of intersection points. We're also going to drag in a new subgraph. This one's pretty straightforward, so we're not going to make it from scratch. Now let's start connecting things up. And I'm going to delete this landscape input since it's not actually used. Alright, first it starts with a branch node connected to the loop index. We also get the saved index of the intersection point. And then we start filtering out the points by the index. The filters for loop 0 will have less than and greater than. Once finished, those densities will be set to 1. The settings of the loops that precede that will be set to the preceding loops after that will have their settings be greater than and less than. These ones will have their density set by the loop index multiplied by the count. Minor cut here since I had to reconnect the rest of the graph in order to get the intersections that we need. And it's a good thing I decided to check on the state of the points because I forgot something else critical. These points right here also need to be partitioned. Since naturally without those intersections the graph won't actually work. Now we can merge the points and self-prune by density. Then partition them by that density. Now we start creating some difference nodes. Making sure to set the density to 1 for this one. Now output 4 will be used to delete from output 2. And output 1 will be used to delete from output 4. Then all 3 of those will be connected into a singular difference node. And from there we'll difference with the cuts and intersections. Alright, next a new loop graph. Because now we need to stretch out the endpoints of the segments. This is because of the way splines begin and end at the point, instead of spawning the mesh at the center like a regular mesh spawner. So what we're going to need for this is the y positive and the y negative. Alright, next we're going to save the index of the points again. We're also going to set the density to 1. And we're also going to create 2 transform points, one for the y positive and one for the y negative. Next we're going to difference these two so we only get the points at the beginning and the end. Then we merge them back together and sort them by their saved index. Now if we press debug, we should see our results. But the results were not what I expected, so time to just go back and see what I missed. And yep, I forgot to connect the transform points. And with that, the endpoints are properly stretching out to meet the intersection points. Now there's still a bit of a gap over here, but we can fix that one later. Next, we have a cut by intersection subgraph. And this one will delete the entire segment if something is placed there like a manual structure. Very handy, but I don't think we'll be seeing the effect of it in this specific example. Although we'll still set things up so it can be used. Now finally, we can project the points and create the spline. Next, we're going to resample the spline and use the length as the distance. Make sure to select unbound and fit the curve. Next, we get a extents modifier and use the length as the settings for that. And the last thing we need to do is a vertical adjustment subgraph, because currently the end of the spline and the intersection will have a slightly different z height. So once again, we're going to use copy attributes to save the index. We're also going to need the intersections. Now we need an attribute filter that will take out the first index in the spline segment. Next, we do two intersections. We also need to project the intersection points. And then we use a bonds modifier to double the size. Plug that into the intersection nodes. And then next we need a lerp node. We're going to use the ratio as 0.02. Then we're going to copy attributes. And then get a 0.2 attribute set. Then back in the copy attributes node, We're going to copy the position C into a new attribute called endpoint Z. And we're going to select that as the only attribute to keep. Next, we're going to create a set node and set the new position C. From there, the points will be remerged. And finally, those points will be sorted by their saved index. Of course, this only affects one endpoint of the spline, so now we need to copy and paste for the next one. And with that, the points are now ready to go. Now we also have a point cutoff graph. By setting the number to 2, any spline segment lower than 1 will be deleted. Next, we have a transform points. This one will offset from the landscape according to a blueprint parameter. And then finally, we get to output our results into the main graph. So what I'm going to do now is add a spline mesh spawner. We're going to give it the main street segment. Alright, it seems I'm not done after all. Turns out I missed a small bit. Since not every endpoint of a spline will meet with an intersection, I need to remerge the ones that don't meet. Now what this part over here does is prevents streets from spawning immediately next to each other. Not too important, all it does is give the streets some extra spacing. Now this part here, as labeled, is meant to stretch out streets that are just a single block away from intersecting. What it does is move the streets back and forth, and if it makes an intersection, the created point will be either added to the front or back of the saved index before being remerged and sorted. So all we're doing is filling in that connecting gap right there. And so now I will show you what it will look like in its final form. Now on to the next segment. In the first video, we did streetlights like this, and in the current graph, we still have it there, although slightly modified. However, there is one flaw with this approach, as we would need to copy this segment of the graph over and over every time we want to add something to the street. Hence, a more repeatable loop of this needed to be created. That is this subgraph right here. Now, it does look bigger and more complex than it actually is, but that's because of all the nodes that we're using just to retrieve settings and blueprint variables. So let me bring those up so you can see them side by side. First up, we have the data asset for holding the meshes for this loop. Here you add the mesh and its mesh specific settings. Nothing too crazy here, and you can leave the default settings on for almost most meshes. Far more important are the settings in the data array. I try to make sure the names are as easy and self-explanatory as possible, but let me know if a particular setting isn't clear. Alright, first we have the spline sampler taken into spline segments. Here we need the distance increment, start and end offset if wanted, random distance if wanted, and fit to curve if wanted. As you can tell, the goal is to make sure each individual loop can have as much of its settings be available for tweaking on their own as possible. Next, we intersect the points with the spline center if it's not too important, but sometimes points will spawn just a little off from the street, so that eliminates that. Next, we reset the density back to 1. I'm not sure if I said this yet, but you'd be surprised how often the point not being the correct density has messed me up. Since many nodes like difference intersection, self-pruning, and other nodes use density in sometimes unexpected ways. The next transform only rotates the points 90 degrees and nothing else. Following that, we can choose to reset the pitch and roll if we don't want the object to follow the rotation of the spline. From there, we can set a position and rotation relative to the spline. And a mirror will also be created if enabled for objects wanted on both sides. We also have a way to delete from the center if meshes are an unwanted distance from the street. Next, we can reproject back to the landscape if some of our settings moved our mesh off the ground. From here, the points will be either merged or continue as separate branches if splines are necessary, because the meshes that you're turning into a spline will follow a slightly different path. Next, the mesh is assigned from the data asset. The method to assign a mesh to a spline is a little different from the way meshes are assigned to just points. With splines, we need to extract the mesh from the data asset and add it as an attribute instead of just matching and setting the attributes. Next, the final adjustments. For the splines, you want to minimize what you change here. Try to have the base mesh oriented correctly from the start to avoid having to make tweaks on every instance. Don't underestimate how troublesome it can be to have to make multiple micro adjustments on every mesh you add. Just have the pivot right from the start and avoid the headaches later. Finally, make sure the spline mesh override is set up to read the given mesh attribute. Fortunately, the regular point spawn meshes don't have as many worries and can be fairly messed around with. They have some nodes we saw in the procedural building video. And then they go through some different nodes that will delete any points that cross with the always exclude input. They also have some optional exclusions, in case you want more control over what meshes get to override others. For example, we can output the optional exclusions here for the next loop. Some self-prune if wanted, and then spawn. Then finally, we output the points in Spline for some additional use cases. Now create the outputs, and we also have an additional variable here called graph label. This can be used to filter out any specific loop that you want to single out for its own operation or for whatever reason. Now back in the main graph, let's go over how we get some of these inputs, since some of them need information from objects in the scene. So over here we have 3 separate segments for that. The first has 2 get spline data nodes that will get the water body river. All you really need for those is a spline sampler and some adjustments to the point bounds. I might also add some blueprint parameters for these, but I doubt there will be much reason to change them. Below that we have the manual spline objects. I try to make them as drag and drop as possible. And one of the key factors for this is being able to get the PCG details of each individual item you drop into the scene. As an example, I'm going to show you the graph of a bridge spline I made. I won't go over the details of this one quite just yet. For now, all you need to know is that you can start filtering out the points you receive from this graph using attribute filters. So as long as the points are properly labeled, you can use the points from one graph in another graph that would otherwise be unconnected. Let me show you how this works real quick. As you can see, if you drag one part of the spline downwards, it will cause the city graph to delete a segment of its street. Now you might ask, what if we don't want to delete from the street? What if we want to delete from the bridge instead? Well, that too is possible. By passing over the bridge points over into the main graph, we can use the main graph to delete the bridge points from the spline graph. And then lastly, the third segment goes for manually placed structures. As long as it is correctly tagged, the PCG graph can use it. Oh, and I think I almost forgot to explain how the bridge columns are actually created. First, we get the spline data. We save the index. Then we loop through each spline. We project to the ground and create 2 points, one on the ground and one on the bridge. Those 2 points are then merged together into one singular spline. This spline will stretch from the top of the bridge to the bottom on the ground. And now you can use that spline to create points that will become the columns. And now you can start splitting those columns to decide what is the top column, middle column, or bottom column. Although in most cases I believe you will just use the same mesh. We also delete any columns that are too close to the ground, since columns are not necessary in that case. Finally, the mesh is assigned. We delete any columns crossing over manual structures, and then we spawn the mesh. And also, of course, we have a spawn meshes along the spline subgraph over here. In this case, specifically for the bridge. Alright, I think that's long enough for one video. We'll continue in the next.